You know, when you look at the phone in your hand, or even just the walls of your house, do you ever stop and think about the epic story hidden inside? Today, we're going to follow a hero on an incredible journey. It's a saga of massive engineering, geology, and chemistry that starts deep inside the Earth and ends up powering, well, pretty much everything we do.
I mean, just think about it for a second. This stuff is in our phones, it's in electric cars, it's in the pipes that bring us water, and it's in the huge power grids that light up our cities. It's this silent hero, working away in the background, the true protagonist of our modern age. Any ideas what it is?
If you guessed copper, you got it. You're absolutely right. This humble reddish-brown metal is without a doubt one of the most essential materials for our society. But its journey from just a piece of rock to a vital piece of our technology is anything but simple.
So, what's the big deal with copper? Why this metal and not something else? Well, it all comes down to this really unique combination of properties that makes it pretty much the perfect material for a ton of different things. What's so amazing is how all these properties just work together perfectly. I mean, its ability to conduct electricity is legendary. It's literally the backbone of our entire electrical world. It doesn't corrode easily, so it lasts a really long time. It's so flexible, you can draw it out into these tiny, tiny wires. And maybe best of all, you can recycle it over and over and over again without it losing any of its quality. It's a true super metal.
But before copper can be any of those things, it has to be ripped out of the Earth's crust. And this is where our story gets absolutely colossal. The first stage of copper's journey is a trial of pure, brute force and some incredibly precise engineering.
Okay, to really wrap your head around the scale of this operation, just look at this number. 200 tons. To get the copper we need, miners have to dig up and move, on average, 200 tons of rock and ore. That's about the weight of 33 elephants. And all of that material is for what exactly?
Yep, all that work, all that rock, for just 1 single ton of pure copper. The amount you get out is just tiny compared to the rock you have to move, which means the machinery and the whole process, well, they have to be just gigantic.
And when I say gigantic, I am not kidding. We are talking about trucks that carry 400 tons. That's the weight of a small commercial airplane. We're talking about excavators that can lift 80 tons in a single scoop and drills that bore holes as deep as a 5-story building. It's like this massive industrial ballet on a scale that's just breathtaking.
So how do you actually break up all this rock? Well, they drill around 130 of those super deep holes, and then they load them up with a really potent explosive mixture. Then from a safe distance, an operator sets them off in this rapid-fire sequence, just milliseconds apart. Each blast is powerful enough to level a building, but it's all so precisely engineered to shatter the rock just right, getting the most copper with the least amount of waste.
So once all that rock is shattered and collected, our hero, the copper ore, comes to this critical fork in the road. See, not all copper ore is created equal, and the path it takes from here depends completely on its chemistry.
You've basically got 2 main types of ore. You have oxide ores, and those get processed with acid. That's a journey of chemistry. And then you have sulfide ores, which take a much more complicated path that involves some really intense heat, a journey of fire. So 2 very different challenges that need 2 very different solutions.
This part right here is the alchemical heart of the whole process. This is where raw rock gets transformed into one of the purest metals on the entire planet. Let's follow that acid path first.
For the oxide ores, the process is called leaching. They make these gigantic piles of the crushed rock, and then they basically just irrigate them with a sulfuric acid solution. For weeks, this acid slowly seeps and trickles all the way through the pile, dissolving the copper and carrying it away, leaving all the worthless rock behind.
This liquid, which is now rich with copper, gets collected and concentrated. Then it moves into these special tanks where the real transformation happens. They pass an electric current through the solution, and that causes pure copper ions to literally cling onto these metal plates called cathodes. Over about 10 days, these plates get thicker and thicker with copper that is nearly 100% pure. But what about that other path? What about the sulfide rock? Well, getting copper out of that stuff is a much more intricate process. It doesn't start with acid. No, it starts with pure mechanical force and a little bit of clever chemistry. First, they take the rock and they pulverize it into a fine powder inside these gigantic rotating mills that are filled with steel balls.
Then, that powder gets mixed with chemicals in these big flotation tanks. Bubbles are pumped through, and here's the magic part. They attach only to the copper particles, lifting them up to the surface in a rich foam. This foam gets skimmed off, creating a concentrate that's already about 30% pure copper.
And just look at this dramatic jump in purity. That 30% concentrate gets sent to a smelter. The first furnace doubles its purity up to 60%. Then it moves to a second furnace, and bam, you're at 98%. After a final purification stage, it reaches an incredible 99.9% purity. Each step is like a fiery trial that just burns away more and more of the impurities.
So why are they so obsessed with purity? Well, it's pretty simple. Even the tiniest little impurity can disrupt the flow of electricity. That 99.9% number is absolutely essential for the demanding, high-performance electronics that we all rely on every single day. From our smartphones to the entire power grid itself.
Okay, so now the copper is pure, but it's still in the form of these big plates. It's not really a material we can use yet. The final leg of its journey is all about shaping it into its most common and useful form.
Those pure copper cathodes are melted down and then cast into a single continuous rectangular bar. This glowing hot bar immediately enters a series of rollers that squeeze and stretch it, transforming it into a thin rod just 7 millimeters thick, all in one seamless process. Finally, this finished rod is wound into these massive coils, ready for shipping.
And just like that, the whole saga concludes. From a fragment of rock buried deep underground, through explosions and acid baths and fiery furnaces, our hero has been transformed into a coil of pure potential, ready to conduct the electricity that powers our civilization.
It is an incredible story of transformation. But, it leaves us with a pretty critical question. As our technology and our need for electricity just keep growing, so does our demand for this essential metal. And it makes you wonder, what's the next chapter in copper's journey? What happens when the easiest to reach rock is all gone? Definitely something to think about.